Ionic solids are tightly packed structures to minimise repulsions between oppositely charged ions. So here we can see, for example, the two-dimensional and three-dimensional arrangement of sodium chloride, which is a solid at room temperature. And here you have strong interactions between the oppositely charged ions, which gives ionic solids different properties, like a low vapour pressure, a high boiling point, a high melting point, and so on. And ionic solids are also brittle, meaning that they fail catastrophically under certain loads. So for example, if you load this ionic structure as follows, then you get sliding of the layers relative to each other, and you may get two like charges as follows lining up. And due to the repulsion of like charges, once you reach the strength of the interaction, the solid will fail catastrophically. So that's what brittle means. And ionic solids only conduct electricity in the liquid phase. So for example, if you dissolve sodium chloride in water or an aqueous solution, then the ions here become mobile, and due to these ions being mobile, they conduct electricity.